In this session, I'm going to be looking at loops and iteration and just looking at some of the key bits of knowledge you need to know. This is going to teach you how to do it. It is just going to remind you about all the things you need to remember and be able to do for the exam. Okay, so there's three main elements that I'm going to be covering today. Flowcharts, how to read a flowchart with a loop in it, and also how to turn it into code. Some common code patterns you'll come across, which you need to be able to remember and be able to recreate, and also how to write loops in a practical way. And here's some example loops that we might see in the exam. So remember, the exam will use the OCR reference language or pseudocode for us laymen, and it does look slightly different to what we do in Python, but hopefully you will be able to recognize a lot of similarity. So on the right hand side, you can see we've got a loop. The key difference is it's got this end while there, and also in Python we'd have the double dots, wouldn't we? Now in Python we don't really have this for loop, okay, but these two bits of code are the same, okay? So you can see I've got a equals 1, that's my starting point, a equals 1 my for loop. Then while it's less than 10, that goes to 9. So 9 will be the last number that will be printed out by this loop. This one is the same as saying less than or equal to. That's the way to think about it. With a for loop, the next is the same as saying plus 1. Okay, that's what that does. The print's the same, and everything else is the same. So when we have a loop in a flowchart, you'll notice that it will go back on itself. It tends to go back to a decision box. Okay, so remember the diamond is a decision. And in this example, it says is a less than 10. So that is my decision. If that is true, then I'm going to do my loop, which means the flowchart will follow down that way. And if it's false, I'll just simply stop. So how does it get turned into code? Well, we take each box one at a time. So the first box says a equals 1. Well, the first line of my code says a equals 1. Okay. The second one is a diamond. Now, normally we'd write a diamond as an if statement. However, because it's got this loop back on itself, okay, that's how I know it's not an if statement. It's going to be a while. Okay. So you'll notice that if statements and while loops have a condition. Okay, so if that condition is true, it will do the code underneath it. So it's very similar in the way it's structured. The key difference is it repeating or is it just doing a selection, a choice once? Okay, that's the way you know the difference. And if you've got something looping back on itself like this, so it's going from the one part of the loop of the flowchart back to an earlier part of it, that's a loop. That's what you're looking for. Okay, then the rest of it is exactly the same. The only difference is because this is part of the yes, okay, you'll notice that it's indented here, okay, because it's part of what we're repeating. So this bit of code, this part of the flowchart which I've circled, I know it's got a bit messy, but sorry about that. The bit I've circled is what's being repeated, which is why it has been indented here. So that's how we can turn a flowchart into code, and that's how we can tell what we have to write. Inside a loop, there are four main parts. Okay, the starting point, and this is, by the way, for counter loop, okay, or counter controlled, however you want to say it. So we have our starting point. What number does it start with? What value does it start with? When should it end? So this loop will repeat while this condition is true. So we have to think about when it ends. In this scenario, it's going to end when x is no longer smaller or equal to 5, i.e. 6 or above. Then we'll have the code we are repeating, which will always come next. And at the end of the loop, I'll have the increment. That's how we get from the start to the end. So our loops have four main elements. The way to think about this excuse me, the way to think about this is it's generating a number sequence or arithmetic sequence. So it starts at 1. Then I add 1 to it. So my next number is going to be 2. Yeah, because the difference between those is just simply plus 1, isn't it? It's a terrible plus. Try again. There we go, that's a bit better. They got +1. Then the next number is going to be 3, then 4, then 5. Okay, so it's creating a number sequence. So how do you write loops? Okay, what I'm going to share with you is just a way to think about it for the exam, just to help you, to give you a bit of scaffolding. However, if you're confident you can write loops straight away, you don't need to follow these 4 steps. Okay. However, if you think, oh, I'm not so good with loops, this might be a good way of doing it. So the first thing you need to do is work out, well, what do I want to do more than once? Okay, that's really important. So in this scenario, I want to write a program that's going to roll a random dice 5 times. Okay, so the thing I need to be able to do is roll a random dice. So ignoring the 5 times for now, I just need to roll a dice. Okay, print it on the screen. So that's the code I need to repeat. So that's what I start with. And that's what I've done here. So the code I'm going to repeat is these 2 lines of code here. Okay, I don't need to repeat the from random import star because I only need the random library once. Okay, so anything you want to do once does not go in my loop. Anything I want to do more than once, what I want to repeat, will go inside the loop. Okay, it's how you know where to put things. So the next thing I need to do is work out arithmetic sequence. Well, I want to roll the dice 5 times. I'm going to roll it once, then twice, then 3, then 4, and then finally 5. Okay, so the number sequence I've just created there is really simple. It's 1, 2, 3, 4, 5. Okay, almost want to say caught a fish alive, but I'm not going to. So the number sequence I generate is that. Now that I know that, I can start writing my loop. So I write my loop using the arithmetic sequence because remember there's 4 elements to my loop: when it starts, when it ends, how it's getting from start to end, and what it's repeating. So let's have a look at that. So I start at 1 because that's the first number in my little sequence there. I'm ending when it's 5 and including 5 because I want to print the 5 out. I want to do the 5th row, which is why I have got less than or equal to. I could, if I wanted to, do less than 6. It will do the same thing, won't it? Then, well, the difference between these two is just +1 each time. That's why I have got throw +1. Notice the variable that I'm using here is the same all the way through my loop. That is really, really important. The last one is the code I wrote in the first step is now going inside this. So my final code looks like this. So notice that I'm creating my arithmetic sequence starting at 1, ending at 5, adding 1. Then inside it, I've got the code I'm repeating, which is literally the code I've just wrote. That's how you write a while loop, a counter-controlled while loop using 4 very, very simple steps. The next thing you need to know is trace tables. Okay, trace tables are how we read code, okay, and how we make a note of it. You might be asked in an exam to do a trace table, and it will normally have the variables inside the code and what the output needs to be. Okay, so whenever you see an assignment or an equal sign, okay, that's when I'll write down a new number. So the first number I'll write down is 5, which is why the first value is 5. Then I hit my print, which is why I've got this line here where it says I have looped with value of 5. Well, x was 5 when that print happened. That's why I print out that. Then I have my x equals x plus 3. Well, 5 plus 3 is 8. And because I've got this equal sign, this assignment, that's why I've wrote down the new value here. Then it's going to loop, so it's going to come back to here and just make that test to see if x is less than or equal to 16. Okay, well 8 is smaller than 16, so I'm going to do it again. So that's why I'm going to print with value of 8. I'm going to add 3 to my x, which gives me the next value of 11. Well, it's still less than 16, so I do my outputs again. Then I add 3 to 11, which gives me 15. Still less than 16. So update it, do my print, add 3 to 15, which gives me 18. Now I do write the 18 down because it has changed, although now 18 is no longer smaller than 16, so I don't repeat it anymore. So that's why the last thing I have is this print done. So whenever you have a trace table, you're looking for two things. When you've got assignment and also when you've got a print. Anytime you see assignment, you write down the new number. Whenever you see a print, you write down whatever you printed. So last bit, condition-based loops. Condition-based loops have the same structure to the counter loops. We have a starting value, but this one normally will be some text or it will be an input. Okay, in this scenario, it's an input. The end condition, well, that's when I wanted to stop. Okay, that end condition basically is going to stop when it's false. So while that condition is true, it's going to repeat. So that one you have to think about a little bit more carefully than the other one. Then you have the code that you read to repeat, which goes in the middle. And then you must, as always, have a way to get to the end. Now, with that one, obviously, you need to make sure that it's similar to however you started off as. So if I want to repeat something until I say maybe stop or no or something like that, this is what the code pattern will look like. So start off with it being yes. So I do want to repeat. I do want to do it at least once. My condition is while that is yes. So while it's yes, I'm going to keep going. I could, if I wanted to, have it something like this when it's not equal to stop. Okay, or end. I've seen that in the exams more than once. So exclamation mark equals stop, so not equals. Once I have this code pattern, I will then end it or get to the end by asking again, or do you want to go again? Do you want to stop? Do you want to end? That kind of question using the input. And then finally, I can shove my code inside it. Okay, so as you can see, it's very similar to what I did before. I've got the start of my while loop, I've got my end of my while loop, and inside it, I've got the code I want to repeat. So what this code will do is it will keep rolling a dice until I say stop or no or end. So that's all the key elements of loops. Hopefully that has recapped and helped you.